Hello, welcome everyone. In this video, I'm going to look at how to convert logs into exponential forms and then exponential form back into the logs. And we are also going to look at solving a couple of equations using each of that method that we're going to learn. So the first one, I'm going to go ahead and look at a log expression, and then I'm going to show you how to convert that log expression into an exponential form. So we have, this is our log expression right here. So we have a log of 8 with base 2 equals 3. So basically we take the base 2 and then we take this 3, make it the exponent of 2, and then that is equal to that, the log of the number that we're taking, and equals to 8. So this is the exponential form of this log expression that we have here. The other one I'm going to look at is how to convert this exponent log function or log expression, log of 27 base 3 equals 3, into exponential form. So we take the base 3, this is the base right here, and we take this number and make it the exponent of that base, and that is equal to 27. And then we have another log expression, log of 1 with base 10 equals 0. So our base is 10, and this 0 becomes the exponent of 10 equals 1. Remember this from the exponents, the law of the exponents, any number raised to the 0th power is always equal to 1. So this is a little review of the exponent property, the basically a number raised to the 0th power. And then we have another log expression, log of 25 with base x equals 2. So x is our base and 2 becomes the exponent, equals 25. Alright, so this is how you convert log expressions into the exponential form. In the next one, I'm going to convert exponential expressions back into the log form. So if we have like if we have this expression, 3 squared equals 9, that's our exponential expression. How do we convert that into the log form? So we write log, this 3 is our base, this 9 is right here, equals 2. So log of base 3, and we're taking the log of the number 9, the equal, whatever was equal to the equal on the other side becomes the number that we're taking the log of. And then whatever was the exponent of the base, it goes to the other side of the equal sign. So this is the log form of this exponential form. And similarly, if we have 2 to the 4 equals 16. So if we want to convert that into the log form, we take log, and then this 16 goes here. 2 is the base, equals this 4 goes here. So we're taking the log of that number with respect to this base, equals the exponent of the base that we had in our original equation. And if we take another example, we have 10 to the negative 2 equals 1 over 100. Okay. So we have a negative exponent. So 10 to the negative 2 is the same as 1 over 10 to the 2. You could do it that way too, which is equal to 1 over 100. Okay, so how do we convert this into the log form? So we take log of 1 over 100 with base 10 equals negative 2. So that's the exponent log form of this right here. Okay. Similarly, if we have 4 to the negative 2 equals 16, 1 over 16. Equals 1 over 16. How do we convert that into a log form? So we have log of 1 over 16 with base 4 equals negative 2. Okay, so that's how we convert our exponential forms back into the log form. Okay. All right, in the next slide, we're going to solve some of the equations that involve the exponents and the logs both. So here we have log of 25 with base x equals 2. Now we're going to convert that into a exponential form. So this is our base raised to the second power equals 25. That's the exponential form of this log form. Okay, so x squared equals 25. Now we know that if x squared equals 25, x would be, it's the 5 square. So if the exponents are the same, the bases are the same, x equals 5, or you can just take the square root. That would be basically 5 right there. Then we're going to go ahead and look at another expression. We have log of x with base 4 equals 3. In the exponent form, 4 to the 3 equals x. And what is 4 to the 3? Which is 64 equals x. So that's how you solve for x in this one. And I'm going to do one more example. We have log of x with base 3 equals negative 5. I'm sorry. I'm going to just make it negative 2 instead. Would be easier. Negative 2. So in the exponent form, 3 to the negative 2 equals x. Now 3 to the negative 2 is the same as 1 over 3 squared, which is equal to x, and x equals 1 over 9. All right. And then we go ahead and do a few more examples. In this one, we're going to look at log of 32 with base a equals 2. How do we solve this? We convert that into an exponential form. So a to the second power equals 32. Now if we look at it, this is the a squared and this is 32. So what is a equal to? So basically a is equal to square root of 32, because we take the square root on both sides to get the value of a. So if we take square root of this and we take the square root of this, so a is equal to this right there. In the next example, I'm going to look at log of 16 with base a equals 4. Now the exponential form is a to the 4 equals 16. A to the 4 equals 16. Now basically we have to take the, convert the 16th, or taking the 4th root of a to the 4 equal to the 4th root of 16. So this would be a. What is the 4th root of 16? That is 2 to the 4th to the 1 over 4. So basically a is equal to 2 right there. And the next example, we have a little more complicated. Log of 6x plus 2 with base 3 equals 2. Now we're going to convert this 3 to the 2 equals 6x plus 2. 3 to the 2 is 9, which is equal to 6x plus 2. And then you subtract 2 from both sides. So we have 6x equals 7 and x equals, you divide both sides by 6, you get 7 over 6. Okay. And there's one more last example. I'm going to work it out in here. Log of 3x minus 2 with base 4 equals 3. I'm going to convert this into exponential form. We have 4 to the 3 equals 3x minus 2. 4 to the 3 is 64 equals 3x minus 2, and you add 2 on both sides. So you have 66 equals 3x, and then you divide by 3 on both sides. I hope you can see that. So you get x equals 22 from here. So that's how we do it. Hopefully that helps.